Right, so good day everyone. So for the class, our discussion will be all about micromeritics. So for the content of our discussion for today, we will be simply talking about first particle size, okay, followed by the methods for determining particle size, then density and flow properties of powders. Okay. So first and foremost class, let's discuss what is micromeritics. So micromeritics class is simply the study of small particles. So alam naman natin class, di ba, that majority of our pharmaceutical products are in their powder form. And powders class are generally small particles. Okay? Kaya class, kaya madalas na pinag-aaralan sa micromeritics would be drug molecules or any molecule class usually in their powder form. Right? Now what are the types of particles that we have? What are the types of properties of particles that we have? So first and foremost class, we have two main types of properties. We have the fundamental, ibig sabihin inherent na ito sa isang particle, and then derived. Pag sinabi natin derived, ito yung mga nanggagaling or mga nakukuha nating values using the fundamental properties. So what are the applications of micromeritics? So there are four ways class wherein we can apply the study of micromeritics. First would be in the release and dissolution of our drug products, especially those products in their powder form. Okay, how micromeritics play a role in absorption and drug action, okay, specifically the particle size, okay, physical stability and dose uniformity of our drug molecules. Okay, so let's try to discuss this one by one. So how does the particle size affect the release and dissolution? Now, first and foremost class, when we say release, ibig sabihin, release from the dosage form. Release of drug from dosage form. Right? And normally, class, we say a drug is released from its dosage form once it becomes a solution. Alright? So, class, the main principle behind this is liberation. Okay? Sabi natin, drug liberation. Drug liberation, class, simply states that a drug is released from its dosage form. And we say that a drug is liberated, okay? Ibig sabihin, natanggal na siya sa kanyang dosage form kapag siya ay nag-exist na in its solution form. Alright? And class, dissolution naman, on the other hand, is the process of turning a drug molecule into its solution form. Alright? Process of converting, hindi man talaga converting ang tamang term dito. Pero sabihin natin, process of converting a drug into solution form. Okay? At kapag nasa solution form na ang gamot natin, sabi nga natin, the drug is already liberated or sinasabi nating release. Alright? So, how does particle size and surface area influence this? Okay? Normally, class, in terms of particle size, okay, the smaller the particle size, PS na lang, suot natin. Okay, the smaller the particle size, ano nangyayari sa surface area? Okay, surface area ng isang particle. Mas lumalaki yung surface area niya. Okay? So, pag sinabi natin, class, malaki yung surface area niya, ibig sabihin, it allows intimate contact of the drug to the dissolution fluids or sa kanyang solvent. Now, tingnan nyo, class, ha? Imagine this. If this is yung particle mo, ganito kalaki, okay, the size of my fist, kunwari, versus a particle class na ganitong itsura. Okay? Between the two class, sino mas madaling mabasa? Okay? Sino mas madaling mag-turn into fluid? Or mag-turn into solution? Is it A or B? Well, obviously, class, for this case, B will turn into a solution much faster because of the fact, class, na mas maliit ang kanyang surface area. Okay? Mas malaki ang kanyang surface area, allowing it to be easily wetted, okay, by the dissolution fluids. Right? So basically, class, a decrease in particle size, again, increased surface area. Okay? And therefore, class, what happens now to dissolution? Sabi natin, pag mas mataas ang surface area, mas mabilis mabasa. Okay? Or mas mabilis mabasa yung particle. So pag mas mabilis siya kasi nababasa, ano nangyayari sa solubility niya? Okay? It causes an increase in solubility and therefore increase in dissolution. So the smaller the particle size, class, ano expected natin sa dissolution rate niya? mas mabilis. Okay? Mas mabilis siya maging solution. Kasi, sa lahat, pag maliit ang particle size, malaki ang surface area. Pag malaki ang surface area ng isang particle, mas mabilis siya mabasa. So, therefore, mas mabilis siya mag-turn into solution. Now, please take note, class, there are exceptions to the rules, or to this rule. Okay, not all drugs class should be, yung kanyang particle size should be reduced. Okay, not all the time. There are certain drugs class like hydrophobic drugs wherein hindi siya pwedeng masyadong maliit. Kasi ang nangyayari naman, pag masyadong maliit ang mga hydrophobic drugs, or you reduce its particle size, nag-agglomerate sila. Nagdidikit-dikit naman. Okay, so sayang yung effort ng pag-reduce sa kanyang particle size. Alright? So I hope that's clear. Next one. How does particle size affect absorption and drug action? Okay, so basically class, parang ganito lang naman yan eh. Kapag ang gamot ko, mas mabilis ang dissolution. So sabi natin, reduce particle size equals increase in dissolution. Okay, mas mabilis siya maging solution. Now class, kapag mabilis maging solution ang isang gamot, ibig sabihin, okay, mas mabilis siyang mag-exist in its aqueous phase. Okay, equates to higher, okay, aqueous. Okay, nag-exist siya in its aqueous phase. And remember class, what's the number one requirement for absorption? Sabi natin, for absorption, a drug must be water soluble or should exist in its aqueous state. Okay? For what reason? Kasi class, ang dugo natin is actually made mostly from water. Okay, gawa sa tubig ang ating dugo. So therefore class, yung mga water-soluble compounds, okay, mas mabilis ngayon pumasok or mag-dissolve sa bloodstream natin. So therefore class, a reduction in particle size again is said to increase dissolution. And once a drug is existing in pag mabilis ang dissolution ng isang gamot, okay, mas mabilis siya nagiging aqueous phase. At kapag aqueous phase agad, ano nangyayari sa absorption? Napapabilis ngayon yung absorption ng ating gamot sa katawan. And hence class, dahil mabilis siya ma-absorb, ano yung expect natin sa drug action? Okay? So we say it leads to a fast drug action. Okay, so increase in rate of absorption, therefore leading to faster drug action. Alright? So I hope that makes sense. Okay? So pwedeng faster, pwede rin naman greater kasi mas mabilis siya na absorb. Okay, so mas lumalakas lalo yung effect ng gamot na yon. So that's how particle size class, that's the reason why particle size is very important, especially when designing drug molecules. Pero again class, I would just like to pinpoint na hindi all the time maganda mag-particle size reduction. Okay, such as, example ko nga kanina, hydrophobic drugs. Ang nangyayari is, the more you reduce its particle size, the higher its tendency to aggregate. Alright? Now, in terms of physical stability, it has always been believed, class, that particle size in a formulation influences physical stability of suspensions and emulsions. Now, the smaller the particle size, okay, ang expectations dyan is mas tataas yung physical stability niya. Okay? Because it's more compact. Right? So, mas madali siyang i-process ng katawan natin. Alright? Now, what about dose uniformity? Di ba, class, mas madaling makakuha ng uniform doses kung ang iyong particles ay maliliit. Just imagine class if, say for example, in a suspension, hindi siya powder, parang as in, ito yung bote natin, ganito kalalaki yung particles. Okay? Bato-bato. Right? Imagine class, can you get uniform doses kung bato-bato ang laki ng mga drug molecules nyo? Di ba ang hirap nun? Pero class, kung ang drug molecule natin is in powder form, very fine, small particle size, okay, mas mabilis siya class i-scatter, okay, pag inalog mo yung suspension natin, and therefore class, you get uniform dosing. Okay? What if halimbawa, nung pag-alog mo, ito lang nakuha mo, okay, hindi mo nakuha yung rest, di ba? So, stuff like that. Alright? So, I hope that that's clear. So, good flow properties of granules and powders are important in the manufacturing of tablets and capsules. So, meaning the tablet or the powder should be able to flow properly. Remember class, when we're compounding tablets, capsules, basically class, all of the drug products that we're using are in their powder state. Okay? Another reason class why powders or powders generally have higher stability as compared to liquid preparations is simply because of the absence of water. Okay, alam niyo naman, di ba? Water catalyzes so many reactions. At the same time, it becomes a medium for bacterial growth or microorganism growth. Right? Now let's talk about class particle size. So, as I mentioned a while ago, there are two types of properties for particles. So, pwedeng fundamental, pwedeng derived. So, sabi nga natin, fundamental is something inherent sa isang particle, in an individual particle, such as size, ano yung shape niya, density, volume. On the other hand, a derived value or a derived property is a combination of the fundamental properties. So, you get density, okay, granule volume. We'll talk more about this as we go on. And of course, porosity. Now, here are some of the description class of how we describe a particle, okay, based on its size, right? So we say class that a particle is coarse if its particle size is greater than 1,000 micrometers. Conventional, kung between 50 to 1,000 micrometer, and so on and so forth. So ultrafine class is said to have a particle size of less than 0.1 micrometer. Now, how do I get now the particle size? So yun ang tanong natin next eh. So what are some of the methods used to determine particle size? So there are so many methods here. So the first method class I will be discussing is about optical microscopy. So obviously class, anong gamit natin dito? Okay, we're using a microscope here to measure individual particle size. Okay? Now, of course, class, the advantage here is you can actually see the particles themselves. Ang problem lang dito, class, is it's very tedious. That's one. And number two, you only see a 2D image of the particle. So, kung titingin ako sa microscope, ang makikita ko ganito lang. Ganyan-ganyan. I don't see the 3D structure itself. So, kung ganito tingin ko, sabi ko, maliit lang pala siya. Pero pag titingnan mo yung 3D structure niya, yung pala, pag ganito yung kanyang itsura, parang rod. Pero nakita ko yung cross-section lang nung rod na yun. So, ibig sabihin, mas malaki pa pala siya in reality. So, that's one of the disadvantages, class, of using optical microscopy. Okay? Now, when doing optical microscopy, class, there are three measurements that we can do here. We have the ferret diameter, which is the two tangents separated by the longest distance. Okay? Martin diameter, which is the distance that will bisect the particles into halves. So, yun yung mina-measure mo. And then the projected area of the circle. So, diameter of the circle that will enclose the particle. Pero please take note, class, most of this you can only see through a 2D lang nakikita mo. 2D image lang. Okay? So, again, that's another disadvantage of using optical microscopy. Next one is sieve analysis. Now, this is probably the easiest one. Ano ang gagawin natin dito? Gagamit na tayo, class, ng pangsala. Okay? Try nyo na ba mag-bake? Okay? Di ba pag nagbe-bake, meron tayong pangsala. Sieve ang tawag doon. Okay, a sieve, class, is parang ganito. Tapos may mesh wire siya dito. Parang strainer. Yun, strainer nga pala tawag sa kusina. Okay? So, di ba kasi nataktak natin, ibubuhos mo yung flour doon, tapos tataktak mo ganun. Para lumiit yung particle size or para lumusot yung mga maliit na particle size. Now, class, the sieve analysis is actually one of the most basic way of measuring particle size. Okay, we use that for it's a USP standard. All right? And usually, class, we identify the number or the particle size of a powder or a particle, okay, based on the mesh number found in the sieve. So, a disadvantage of this class is the attrition of particles. When we say attrition, kakataktak mong ganyan, nadurog mo pala yung particle, kaya siya lumiit. Okay, so that's one disadvantage of using the sieve analysis. Now, here are examples, class, of mesh size number. Okay, so meron kang 20, 40, 60, 80, mesh. Okay, mesh number. Okay, so the mesh number, class, dictates the number of openings per linear inch. Okay, so how many openings are there per inch? Okay, of course, class, the higher the mesh number, ibig sabihin, mas maliit yung particle size na nakakalusot sa kanya. So between 20 and 80, the smallest particle size na lulusot would be sa 80. Alright? Kasi in 1 inch, 80 ang butas na yun. So ibig sabihin, sobrang compact ng mga butas na yun. Alright? So again, tandaan nyo lang, the higher the mesh number, the smaller the particle size na lulusot doon. So 20 is the most coarse. Next apparatus or next way, class, that we can determine particle size is through sedimentation method. And the apparatus class that we use for this is called the Anderson pipette. Okay, so I just remembered, this was actually one question sa quiz B namin before. Okay, which of the following apparatus is used for measuring particle size using Stokes' law? Okay, Stokes' law, remember class? It's all about sedimentation. Sedimentation rate. Alright, so again, the apparatus is Anderson pipette. Okay, so ano ang mini-measure nandito? How fast will the sediments form? Okay, di ba sabi natin class, if mabagal bumagsak yung particles, ibig sabihin, masyado siyang maliit kasi masyado siyang magaan. Pero kung malaki ang particles, ano expected natin sa kanyang sedimentation rate? Mabilis. Alright? So, decreased velocity of fall equates to a smaller particle size. Alright? Or sedimentation. Decrease in sedimentation rate. Okay? Next one. Automatic particle counter. So we have here class what we call the Coulter counter. Okay? Ang Coulter counter naman class, ang principle na ginagamit niya is electrical resistance. Okay? So it measures the changes in electric resistance being offered by the powder. Now, ang relationship class between electrical resistance and particle size is simply directly proportional. Meaning, kung less ang resistance, decrease in electrical, ER na lang. Electrical resistance, sinasabi natin, maliit din yung particle size. Bakit? Kasi maliit siya. Ibig sabihin, nakakadalo yung kuryente. Hindi niya nare-resist yung pagdaloy ng kuryente. Unlike class, kung malalaki yung particles, okay, so halimbawa, ito yung mga particles natin. So class, ang bilis tagusan niya ng electricity. Okay? Class, kung ang particles ko ganito, malalaki. Okay, di ba mahihirapan tumagos yung kuryente sa malaking particle size? Right? So, yun yung mini-measure niya, the amount of electrical resistance. Tapos, class, itatranspose ng, ng apparatus na yan, okay, yung resistance, yung resistance na yon, electrical resistance na yon, i-convert niya yun into a value for particle size. So, alright? So, again, electrical resistance is directly proportional to our particle size. Next one is the HIAC, or the Royko instrument. And the principle involved here, class, for this apparatus is light blockade. Okay? So, light blocking capacity is inversely proportional naman to your particle size. Why? Imagine it this way, class. Okay? Kung maliliit yung particles ko, okay, maliliit yung particles ko, class, ibig sabihin, marami akong way to block the light. Okay? Maraming particles that can block the light. Kasi maliliit lang siya eh. So, ibig sabihin, pwede mag-bounce off in any particle. Okay? Sa any particle na nasuspend, halimbawa, okay, kaya-kaya nang i-block yung transmittance ng light. Class, kung malaki yung particle size ko, kung malaki yung particle size, class, obviously, may mga butas yan na malalaki din. Kasi malaki siya eh. So, kayang-kaya siya, class, tagusan ng ilaw. Okay? That's the reason why light blocking capacity is said to be inversely proportional to particle size. Okay? So, are we good? Okay. So, ayan. Light blocking capacity. So, let's just write this one down. Okay? So, decrease light blocking capacity equates to increase in particle. Oops, di nakasya. Size. Okay? Okay. Next one, the Gell-Mann counter. Right? Ito naman, class, ang Gell-Mann counter, ginagamit niya naman ang principle of the Faraday-Tyndall effect. Okay? So, what happens here? Again, this one involves naman, class, the scattering of light. Okay, hindi siya light blockade, unlike the apparatus a while ago. This time, class, the scattering of light. Now, class, smaller particles kasi tend to scatter shorter wavelengths, like blue or violet. So, ibig sabihin, if I pass through white light, okay, if I pass through white light sa isang particle, isang powder, if it has smaller particle size, it tends to scatter more of blue and violet color. So, hence, class, meron akong device, a photodetector, that would detect those kinds of light. Okay? Kung majority ng disperse niya is blue and violet, then I can say that my drug, or my powder, or my particle is very small. Pero kung yung particle na yun, class, emits wavelengths, okay, or colors like red and orange, then that would indicate, class, then that's a yung photodetector natin, okay, then that would mean, class, that the particle size is large. Alright? Okay. Next, let's talk about density of powders. So, sabi nga natin, class, di ba, density. Ano ba formula ng density? So, sabi lang naman natin dyan, that's simply weight over volume. So, usually, ang units na gamit natin dyan would be gram per ml. Okay? Now, a powder, class, tandaan nyo to, ang powder, pwede nating siksikin. Correct? Okay, pwede siyang isiksik. Kumbaga, pag nakita ko kasi diba ng lupa, okay, yung lupa, ilagay mo sa isang baso. Okay, di ba may mga spaces in between yan? There are what we call voids. Okay, may mga spaces in between yan. So, halimbawa, ito yung baso ko, kunwari. Okay? Pag nilagyan ko yan ng powder, sabihin natin lupa, there are spaces in between, right? There are spaces in between. Now, pag yan ay siniksik ko, pwede kong siksikin pa yan. Correct? Para mabawasan yung mga voids na yan. Okay? Now, normally, class, a powder, during tapping, okay, pag tinap mo yan, pag sabi natin class tapping, ito yung pagsiksik. Okay, sabihin natin siksik to. Okay? Particles gradually pack more efficiently, and the powder volume decreases, and therefore, the tap density starts to increase. Okay? So, are we clear? So, class, take note, this two here, okay, itong dalawang example ko dito, A and B, may have the same weight. Let's say, for example, 2 grams. But they occupy different volumes. Okay? They occupy different volumes. Ang A class, ang tawag natin dito would be its bulk. Bulk. Bakit? Wala pa akong ginagawa sa powder eh. Pag siniksik ko na yan, pwede yan na yung aking tinatawag na tap. Okay, that's already a tapped powder. So this one class, if I was to compute for its density, so kunwari, initially, ang napuno niya would be 50 ml. Nung siniksik ko na siya, 30 ml na lang yung volume. Okay, so if I compute for its density class, so that's for letter A, so that's 2 divided by 50, I get its density would be 0.04. Okay, for B, pag siniksik ko na siya, ano nangyari sa kanyang density? Okay? So, ito naman, naging 0.2 divided by 30, tama, 0.06. Okay, that's gram per ml. Okay? So, the same powder class, pero since it occupies different volumes, so magkakaroon din class ng difference sa kanilang sa kanilang density. Alright? So, actually, this will now be known as the bulk density. Alright? Yung inoccupy niya lahat ng space, including the voids. And this will now be known, class, yung 0.06 ko. Okay, yan yung aking true density. Okay? Bakit siya true density? Kasi nawala na yung voids. Okay, tinanggal natin yung voids dito. Okay? Kasi siniksik ko na siya, kumbaga. Alright? So, I hope that makes sense. Okay. So, as I've said a while ago, there are two types of densities. We have the true density and the box density. Again, pinagkaiba lang naman yung class. Pag true density, yun yung tinanggal mo na yung yung volume ng pores and voids in the powder. Kumbaga yung siniksik mo na kumbaga to. So, this one is true density. I-compute ko man yan. Ito naman yung bulk density. Okay? Kaya siya tinawag na bulk density because it still includes the volume of all pores within the powder sample. Kasama yung void. Okay? So, kumbaga yung space na inoccupy ng void, tandaan nyo, yung void na yun, hangin lang yun. Okay, may mga hangin-hangin yan. Alright? Next one. Our next property, we have porosity. Porosity class simply talks about the degree of void or empty spaces. Okay? Now, we have to remember, class, okay, that these voids can either be within the particle itself and between the various particles. Okay? Pero sige, I'm getting ahead of myself. So there are the three types of volumes class regarding porosity. Okay, we have the true volume or true particle volume. Ibig sabihin, pag true volume yan, excluded na yung voids. Okay? Tinanggal natin yung mga voids na yon. Granular volume. Okay? Ibig sabihin, kasama pa dyan yung mga the voids within the particle. And then we have the bulk volume. Pag bulk volume naman, kasama yung porosity or yung voids from particle to particle. Okay, now class, for types of porosity, so we have the terms intraparticle and interparticle porosity. Pag sinabi natin class intraparticle porosity, remember, if this is one particle, okay, di ba class ang isang particle, lalo na pag powder yan, may mga maliliit na butas yan sa loob. Okay, which is mainly composed of air lang yan. Okay, that's what we call the intraparticle porosity. Okay, the porosity of one individual particle. Okay, the amount of void in one individual particle. Right? I hope that makes sense. Okay, di ba kasi parang sponge? Di ba? Pag hinati mo yung sponge, may makikita ka mga butas-butas. Those are the voids. Okay, that's considered class to be the pores. Okay, so the amount of pores class is referred to, or the degree of the voids in a particle is said to be porosity. Now that's intraparticle porosity. Pag interparticle porosity, ibig sabihin, that's the void created between various particles. So, this is a gap. This is a void. Yan, mga voids yan, di ba? These are voids, voids, voids. Okay? So, that's called class interparticle porosity. Total porosity would simply combine intraparticle and interparticle porosity. Right? So, I hope that makes sense. So, in terms of type of volume, so we have the following. Okay, so for true volume or the particle volume, this is the volume without the void. So, ibig sabihin class, pag siniksik ko na yung particles ko, okay, kung sa Ilonggo pa ay dinasok na, okay, nakalimutan ko siksik sa Tagalog, tama. Okay, pag siniksik mo na yung particles class, matatanggal natin yung mga voids na yun, yung hangin, yung excess hangin sa mga particles natin. And that's how you get class the true volume. Now, for granular volume, it's simply the volume of the particles together with their intraparticulate spaces, granules. Ibig sabihin, yung intraparticulate spaces na yon, okay, how much volume is it occupying? Yung kumbaga yung mga butas or yung pores within an individual particle. All right? So to get class the granular volume, you need your true volume or your particle volume. Just add their class the intraparticle spaces, the volume that's being occupied by the intraparticle spaces or the intraparticle voids. Alright? So to get bulk volume naman, okay, bulk volume class simply the mass of the powder divided by the bulk volume. So to get this naman class, you need your granular volume, okay, which of course dito sa granular volume, this is true volume, okay, plus yung volume of the intraparticle particle spaces. Okay? Now, class, true volume plus intraparticle spaces plus this time naman interparticle spaces, yung volume occupied. And with that class, you get your bulk volume. Ito yung volume class na hindi sinisiksik na powder. Okay? Ito yung powder na hindi pa sinisiksik. Okay? So, in terms of types of porosity, sabi ko nga, dalawa lang naman yun, interparticle or intraparticle. Pag interparticle, that's the porosity or the void between particles, the volume of the void. Okay, tapos pag intraparticle naman, it's the porosity within an individual particle. Okay, so kung mga class, ito lang naman yan eh. Ito, this is interparticle. Interparticle porosity. Okay, kasi that's the space or the void between particles. Ito. Halimbawa, ayan. Those are interparticle porosity. Now, intraparticle porosity, ito yun. Yan. Intra. The spaces within an individual particle. So, how much space is that occupying? Alright? So, there are devices class that we can use to measure this one. One is electron microscope. Okay, just to determine ano yung space na ino-occupy niya. Now, using electron microscope class, you can actually get a 3D image of these particles. Amazing, right? Okay. So to compute class for intraparticle porosity, this is the formula. Right? So that's just simply granular volume minus your true volume. Okay, divided by the granular volume. Okay. For interparticle naman, a bulk minus your granular volume divided by the bulk volume. Total porosity is simply bulk minus your true volume divided by the bulk volume. Right? So napakadali lang class. I don't think I need to explain how to use this formula. Right? It's very basic. Next one, the flow properties of our powders. So flow properties of our powders, we can evaluate this using three computations. Okay, so we have the angle of repose, okay, the Carr's compressibility index, and the Hausner's ratio. Carr's compressibility index class and Hausner ratio is technically the same. Okay? I mean, well, iba yung formula nila, pero ang kino-compute nila is simply how well can you compress a powder. Okay? So of course, class, the more pag mas na-compress natin isang powder, syempre mas maganda siya. Kasi kaya na siya i-compact. Okay? Angle of repose naman, class, would talk about the flow property of your powder. How good is its flow kapag tinaktak ko from its container? Now, remember, class, to get uniform volume, kailangan maganda ang pag-flow ng isang powder. Kung halimbawa tinaktak mo ngayon, tapos taktak, walang nalalaglag, ibig sabihin pangit yung flow property ng powder na yon. So, kung pangit ang flow property ng powder na yon, anong masasabi ko sa uniformity in terms of giving a dose? Di ba pangit din? Kasi hindi mo makuha completely. Kaya nga class, it's very important that powders should have good flowability, good flow properties. And again, one of the ways we can compute for that, or we can assess the flow property of powder, would be the angle of repose. Okay? Another requirement class, another thing kung bakit kailangan maganda ang flow property ng powder is that, tandaan nyo, dadaan yan sa mga tubes ng mga machines natin. Kung yan class ay didikit sa gilid ng mga tubes, again, mababawasan yung dose na pwedeng magawa, yung magagawa nating dose sa isang dosage form. So kaya kailangan class laging madulas yung powder natin. Kaya nga class, for powders na pangit yung kanyang flow properties, anong nilalagay natin? We put lubricants. Okay? Lubricants or glidants. Okay? Para mag-glide yung powder sa mga tubo ng mga machines natin. Okay? So these are some things class that can improve. Sasabi natin, these ones improve the flow properties of powders. Okay, these are things class that these are excipients na matututunan nyo sa dosage form. Right? Tapos biglang binalikan kayo, no? Sabi niya, hindi, matututunan nyo sa physical pharmacy. Well, at least now, nasabi ko na, di ba? So, lubricants and glidants class, they improve the flow properties of powders so that you can get uniform dosing. Okay, or pag gumawa tayo ng dosage form, uniform yung makukuha nating content. Okay, kaya napaka-importante na dapat maganda ang flow property ng ating powder. Parang suspension sa emulsions, right? Okay, so for the angle of repose, ano ba ito? Okay, so it simply talks about the maximum angle possible between the surface of a pile of powder and the horizontal plane. Okay, now class, to get the angle of repose, okay, it's simply the inverse tan, okay, tangent, yung sa calculator natin. So, di ba makikita mo dyan, ayan. Okay, you can see here tan. Ayan yung tan. So, to get the inverse tan, okay, just simply press shift tan. Try nyo yan ka sa calculator nyo, ang lalabas dyan, tan -1. Okay, so that's the inverse of the tangent. Right? And then simply class, ang gagawin lang natin is to divide it to the ratio of the height created by the pile of powder, yung height na na-create niya, divided by the radius form. Now remember class, kapag nag-flow ako ng powder, nagtapon ako ng powder halimbawa, okay? Nagtapon ako, ganyan. Di ba kasi habang nagtatapon ako, like say for example, in an hourglass, ayun, maganda example to. Okay? So, di ba kasi in an hourglass, parang ganyan yung tsura niya. Parang ganyan. Di ba powder yon? Powder ang gamit natin. So, habang class tumataktak siya dito, notice, di ba nagka-create siya ng parang cone shape? Okay, it creates a cone shape, right? So, palitan natin muna yung color. Wait lang. Okay. So, di ba class, habang tumataktak yung powder, it creates a cone shape, like this one. Ang angle of repose class tries to measure Okay? Yung angle na po-form nung cone shape na yan. Okay, that's the angle of repose. Now, kung ang powder ko class, ang itsura niya parang ganito. Ay, sorry. Ayan. Pag ganyan. Ibig sabihin, hindi siya bumabagsak. Hindi siya nag-spread ng maayos. So, dahil hindi siya nag-spread ng maayos, ibig sabihin, nagsisik-sik-sikat or nagdidikit-dikit yung powders, correct? Compare that class to this A scenario. Okay, compare that class to this one. Okay? Kung ganyan ang itsura class sa letter B, okay? So, between letter A and letter B, sino sa tingin ninyo ang mas maganda ang flow property? Okay? So, for this case class, it's letter B. Bakit? Kasi class, ibig sabihin, mabilis lang siya mag-flow. Okay? Hindi siya nagdidikit-dikit. So, ibig sabihin, yung flowability niya is fluid. Okay? Mabilis lang siya magkumalat. So, class, the lesser the angle of repose is, okay, the higher or the better would be its flow property. Okay? The flow property of that powder. Alright? Okay, so ito lang naman, ipapakita ko lang naman, di ba? So, habang nagda-drop tayo ng isang powder, using a funnel, usually gagamit tayo ng funnel, okay, then let the powder drop from that. Okay, so the less steep, okay, the cone or the powder pyramid is the powder pyramid. Okay, that is created, or the cone that is created class, the less steep it is, the better is its flow property. Alright? So, ito class yung interpretation natin sa mga angle na mako-compute natin. Right? So, tingnan nyo kasi, 25 to 30 or less, that would mean excellent flow properties. Tingnan nyo, the higher the angle is, okay, the poorer is the flow property. Right? Okay. Let's have your sample problem class. So, 100 grams of powder was dropped from a funnel suspended at a height of 20 centimeter. So, usually yan class yung standard. 100 grams of powder, height niya dapat should be 20 centimeters. Okay, so that's pretty standard. So, depende na lang sa protocol ng inyong manufacturing firm. Okay, pero that's the usual standard naman. So, afterwards, okay, an elevation was made, 12 millimeter. Okay, from the surface. Now, the powder was also noted to have made a spread of 5 centimeter. So, when we say spread, okay, so sabihin, kung ito yung kanyang kung ito yung cone na na-create niya, so yung spread na yung class is from this point to this point. Oops. So, 5 centimeters daw yon. Okay, tapos yung height na, yung elevation na kinreate niya would be from this point to this point. And that's 12 millimeter. Alright? So, determine the angle of repose. Right? So, again, ang given natin class, we have the following. Meron tayong height, which is 12 millimeters. And then we have the diameter. Okay, take note, this is not a radius. Kasi from end to end siya eh. So, 5 centimeter. So, obviously, class, to get the radius, you have to divide this by 2. And you get 2.5 centimeter. Now, this one, class, convert na lang natin yung 12 millimeters to centimeters. And as if you can still remember, okay, 1 centimeter is equivalent to 10 millimeters. So, 12 millimeters, therefore, is 1.2 centimeters. Okay? So, sabi natin ngayon, class, angle of repose is simply equal to inverse tan, okay, divided by, multiplied to the height divided by the radius. And that would simply be tan negative 1. Ang height natin is 1.2 centimeter divided by radius, which is 2.5 centimeter. And you get tan negative 1. 1.2 muna divided by 2.5. Okay, so tan negative 1, answer. You get 25.64. And if you look at class D, the graph that we have, this one shows us good, excellent flow property. This excellent flow property is between 25 to 33, right? Or less than that. So that's good flow property. Next one, about compressibility index. So a volume of powder class is filled into a granulated cylinder and repeatedly tapped for a known duration. Okay, so ibig sabihin class, to get the compressibility of a powder, you need to determine class its bulk density and its true density, or what we call the tap density. Okay, so usually class may device tayo niyan na ilalagay mo lang doon yung powder, tapos class may parang plunger that will tap the powder para matanggal yung excess air sa loob. Okay, to get the para mawala yung mga voids and for you to be able to get your true density or your tap density. Okay? So the volume of powder after tapping is then measured. So you just get the mass, bulk volume. Okay? So you get the bulk density. And for the tap density class, simply the mass of the powder. So most likely same lang naman dito sa bulk density, pero magkakatalo lang sila sa kanilang volume. Alright? So dito class obviously mas liliit yung volume na ino-occupy niya. Mas siksik kumbaga. Right? And then class, after getting the density, the individual densities, you get now the compressibility index. Okay, for the Carr's compressibility index class, it's simply 100 multiplied to your tap density or your true density minus your bulk density divided by the true density. Hausner ratio class is a lot simpler as compared to a Carr's compressibility index in terms of formula. But technically class, they just get the same interpretation. Okay, how good is the compressibility? How well can you compress the powder? Okay, so here are some of the interpretations for the Carr's index and Hausner's ratio. Okay, pero this one's class is much better in terms of its flow property, flow characteristic. Okay, so ito lang siya. Okay, you can always interpret this. So let's have a sample problem here, class. So a 10-gram powder was poured into a graduated cylinder and was noted to have a volume of 65 ml. It was allowed to be compressed by pounding the cylinder on the tabletop, and the final volume was reduced by 15 ml. So, ibig sabihin, from 65, nabawasan siya ng 15 ml. Reduced by 15 ml eh. So determine the compressibility index. Okay, so first things first, let's write our given. Okay, so ang ating bulk volume is 65 ml. Ang ating weight is 10 grams. Okay, so ang ating tap volume, sabi dito is was reduced by 15 ml. So that's 65 minus 15, you get 50 ml. Right? So ang required natin is, sabang susulat ito lang. Required is yung compressibility index. Compressibility index equals unknown. So let's compute for both na. Okay? So una sa lahat, kailangan ko muna yung mga densities nila. So let's get the bulk density. So that's simply 10 divided by 65. We get 10 divided by 65, 0.15. Okay, tapos yung tap density, or sasabing true density, that's 10 divided by 50. 0.2. Okay? Now, pwede na kayo mag-compute. So, let's go for Carr's muna. Kasi di ba sabihin, that's 100 times tap density minus bulk density over tap density. Okay, so that's 100 times 0.2 minus 0.15 divided by 0.2. Alright, so do that, you get about 25%. Okay? Now, sa Hausner naman, at least ito madali lang. Okay, that's just simply density of the tap, or tap density divided by bulk density. And that would be 0.2 divided by 0.15. We get 1.33. Right? So do that, class. If you actually look at its interpretation in terms of flow property, class, for both, actually, ang lalabas dyan, both of them are, using both equation, kasi sasabihin nila that the powder is passable. It's not excellent, okay, pero at least pwede na. Passable na. Alright? Okay. Natakpan pala ng video ko yung sinusulat ko. I'm so sorry. Alright, so, I'll just rewrite na lang yung Hausner. Somewhere here. Dito na lang. So, sabi natin yung bulk ng top is 0.2 divided by ito 0.15 and you get 1.33. Alright? Okay. So, other factors, class, that can affect the flow properties of drug. Okay, of course, definitely would be the particle size. The smaller the particle size, class, mas maganda kasi hindi sila magsisiksikan masyado. Hindi siya babara. Yun actually isa sa mga term na hanapin natin eh. Pag maliit yung particle size, lesser ang chance na magbara siya sa mga tubes. So, therefore, improve yung flow property ng ating powder. So, particle shape and texture, kung mas round yan, better, as compared to irregularly shaped powders. So, round kasi, class, less friction. Compare that sa mga angular particles. Okay, surface forces, in terms of surface tension, ganyan. Kaya usually we add lubricants. Okay, and then of course, flow activators like glidants. Okay, so those are things that can improve powders' flowability.